Welcome! In this series of short videos, we will look at topics common to both the PowerBasic console and Windows compilers. Today, we will look at using threads to speed up file processing. Today, we're going to look again at threaded processing. Threaded processing is a means by which you can run several tasks concurrently on your system. If I were to use the analogy of digging a ditch in the land behind your house, you know that using several people to dig the ditch rather than just one person would be a faster process, as long as each of the workers has something to dig with and has enough room to work. So setting up any threaded processing, any parallel processing, involves a certain amount of work at the beginning to make sure that everything is prepared correctly. So what we're going to do today, we're going to take two large files and we're going to perform a process on them to produce output. So the first thing to do is to get our large files. So to do this, we're going to revisit a program we used in a previous video. In a previous video, we created random names using a generate data program. This generate data program creates random information comprised of first names, surnames, locations, eye colour and blood type. We're adding to this email addresses. If we have a quick look at the program, we'll see I've set this particular program up to generate 100,000 records containing our random information. So if we run that now, it has built up a number of arrays, one array for each of the variables, for first name, surname, street location, city location, eye colour, blood group, and also email addresses. So once this has generated our 100,000 records, what we'll want to do is to extract a sample of these records into an extract file. And this extract file is what's going to drive our parallel processing. Now that we've sped to the end of that file generation, we now have a file, mylargefile.txt, which if we open it up, we'll see it has our random data. That has first names, surnames, addresses, telephone numbers, eye colours, blood groups, and an email address. And we'll see if we look for the very bottom record, that does indeed have 100,000 records in there. So, having generated our mylarge file, we're now going to extract from that a random sample of about 10%. So if we run our extract file, we'll see that we've got a extract file.txt, which has in it the old email address and what we want the new email address to be. And this has about 10,000 records in it. So the task we're going to be doing is we're going to be searching the large file for this email address. And we're going to output another file which has the new email address added on as an extra column for those records that appear in this extract file. So we're going to end up with an output of about 9,910 records. So our intention with this program is to compare the time it takes to process the entire file sequentially or to process it in a parallel mode. So the first thing we're going to do is prepare a global array and some constants. We're going to store the smaller extract file in a global array. We're going to read through the large text file. So we prepared three constants. One constant with the name of the extract file, which is the smaller file. one constant that has the current data, which is going to be the large file, and we're going to create a file which will be our output. So in order to measure this, we're going to take a note of the time we start at and the time we finish, so we'll know how long in seconds it takes to process all of this. So we're going to use a quad variable, and this quad variable is going to pick up the timer. So since we're going to be doing this using threads, we need a nice logical way of slicing up the large file into sections. So we'll create a variable for handling the section we're going to be doing. And right at the beginning of the program, the first thing to do is to load the smaller file into a global array. So how we're going to do that is by using one of our standard routines in our file handling library. Read the file into an array. And all this does is it takes two parameters, one being the file we wish to read, and the second parameter being the array into which we want to put the file. Now, as we may be running this program several times, I want to make sure that our output file is well and truly purged before we run each one. So we're going to use a try catch to kill off any instance of the output file or files. And our output file starts with the new file name. In this case, updated current emails. Now, since we plan on doing this in threads later, I put an underscore at the end here so we can add a number, so the section number can be in there. Now we're going to set a couple of extra constants at the beginning for blocks, for sections. We're going to start at section 1 and work to section 5. So a simple for next loop will actually handle that quite nicely. So from the start selection to the end selection, we will run this function for each section. And once the program's finished, we will then output to our log how long it took. Right, so all we have to do now is to create this function. Now it takes a single parameter, which is the section. Now what this function is going to do is quite straightforward. It's going to work out where in the large file to start reading, and for each record in the large file that it's actually read, it will scan the array to see if it finds a match. And if it does find a match, it will output that to our new file. So we'll put some variables in to keep track of what we're doing. And the first thing to do is to work out which row of the large file to actually start at. Now for the first section, the start will be record number 1, and the end will be record number 1 plus whatever block size we're doing. It's going to be about 5,000 records. So since we know our large file is 100,000 records, we're going to process it in 5,000 record chunks. So having determined which record to start at, we now have to open the files. First thing to do is to get a file handle. This is for our input file, and you would normally do an open on the file you wish to open. Now, if we weren't doing anything in threads, this would work quite happily. If we were just doing sequential reading, because the open for input puts an exclusive lock on the file. Now, as we're going to have several threads running all at the same time, each of those threads will be reading this file. So there will be several threads reading this file at any one time. So we can't afford to have an exclusive lock on the file. However, PowerBasic gets you a way to get around that by putting a lock command in. If we put lock shared, that means when one thread opens the file for reading, it will not put an exclusive lock on the file. Now this works fine if all we're doing is actually reading from the file. So having got that set up, we now have to set up the output to our output file. So we obtain another file handle, and we're opening this file, and we're adding on the section number, so the new file has a number on it, as in section 1, section 2, and this one is for output. Now, each thread will be writing to its own file, so there'll be no collisions here. Now, having got that determined, we now have to read through each record in the input file. So this will be a while loop. So while we are not at the end of file of this file handle, which is our input file, we can do a whole line input and put the data into this variable. And then we're incrementing a counter. This is keeping track which line we're actually on. Now if we're on line 1, then it will pick up the headers. So what we'll do is we'll actually store those headers in a variable. So having read the first line and stored the headers, we will then do an iterate command, which basically means it goes back to the while and reads the next record. Now the next thing we want to do is to work out, are we actually a record we need to do something with? Since we've already determined what record we should be starting at, we need to test if the count we're up at the moment is actually at that record or beyond it. So having got the headers out of the way, we need to see whether the record we're reading is one we need to do anything with. So the first test to do is the count of the record we're actually on below the one we should start at? If it is, then this is something we don't need to process and we can just do an iterate. Otherwise, we can go on and start processing. So we're going to use the long process variable to increment our counter. Now we want some feedback on screen to see what the process is actually doing. So we're going to put a message to send out to our log for every 200 records. The mod command is very useful for that. If we do the variable long processed mod 200, it's telling us if the remainder of that division is 0, then we're at a 200 boundary. In which case, every 200 records will throw a message out to the log. This will give us feedback to let us know what the program's actually doing. Next, if the record count we're actually on is beyond where we should be reading, then we'll exit completely out of the while loop. Otherwise, we'll actually start processing. So if we're on the very first line of processing, we can then print out our headers to the top of the file. And we're adding on to the headers this new column, which is the new email address. Now we can pick up the current email by using the parse command. The whole line data is stored in strdata and it's tab delimited. So if we look for the 7th element in that line, that is our current email. And we're going to use a new function to work out what the new email should be, passing it the single parameter of current email. Now we'll come back to that new function in a moment, but we'll just finish off the logic in here. Once we call the find new email function and get back our value, if it's not blank, then we will print it out to the file preceding the new email address with the original data. And at the very end of the program, we will close off both of our files. So all we have to do now is to use the find new email. Now this function is going to take the current email address in as a parameter, and then it's going to search the global array. Now this is a very simple for next loop, for the beginning of the array to the end of the array, doing a case independent comparison between the current email and the value stored in our array. And should we actually find a value, we're returning the new email address, again using the parse command. and as soon as we actually find a match, we will then exit the function, and that will pass the value back. If we get to the end of the array without finding anything, we will return an empty len string. So we'll try a quick compile to make sure we haven't missed anything, which is fine. Now we do for the first to the second sections. What this is going to do is it's going to obviously read the small file into the array. It's then going to scan the large file for the first two sections, each section being 5,000 records. So before we run that, we will need to copy in to our area where our program sits the two files. So if we have a look inside our data folder, we will find our extract file and our my large text file. So if we copy both of those and we paste them in, we can then try running our program. So the program is running through for the first section. It will read through the first 5,000 records, and then it will attempt to read the next 5,000 records, which it's now doing. Once it gets to the end of this, it will tell us how long it took to process all 10,000 records. 25 seconds. It's not bad processing. However, this is only processing 10,000 records of the full 100,000 records. So we can work out quite easily how long it would take to process the entire file. Now, while this process works, we want to speed it up a little by using threading. So how do we actually do that? Well, to save butchering our code too much, we're going to put in a little conditional compilation. If this run threaded constant is actually set up, we can set our program to compile conditionally. So what we want to do, first of all, we need a couple of arrays to keep track of the threads that are actually running. So we're going to use a conditional compilation line called this. So anything with a hash at the beginning is a conditional line. So if this constant here is defined, in other words set up at all, then the next line of code will automatically be used for the compiler. If this constant does not exist in the program, then the next lines will be ignored. So we're setting up two dimensions here to dimension an ID thread array and an ID thread status array. Now we've already set up a constant for the total sections, which at the moment is currently 2. So this means we're going to be using 2 threads, one for each section. Further down where we actually call the function that does all the work, we're going to put a bit of conditional compilation in there as well. If runThreaded is defined, we will compile the code within this block. If not, we'll do the code in this block. So what we will do is we will put a piece of code in here which is very similar to what we've done before. Only the difference being is we're using thread create in front of the function name. And in addition to that, we have a to command on the end, which means we're going to store the thread information inside this array. So for section 1, the first element of the ID thread array will contain the thread handle. For thread processing, rather than what you would do normally when you call a function, when we call this function originally, the program will wait until that function is finished before we get down to the next line of code. However, when we launch the thread, the code execution will continue immediately on the following line. Now, we don't want the duration to be calculated at that point because the processes will still be running in the background. So what we need at the end of our program is a bit more conditional compilation. So we're going to create a function called waitForThreads. It takes a couple of parameters, the total number of sections and the array that holds the thread handles. Now once this actually finishes, then the program can be finished. Now the wait for threads function will be generic to any kind of thread handling, so we can use this for all our programs that are going to be using threads. So there is the wait for threads. So it's taking in the thread to wait for, in other words our section, the array, and the start thread index. So we'll start at number 1. And this basically is calling a Windows API function to wait for multiple objects. And should any Windows error appear, it's calling another function called Windows error $. So with that in place, we now have to look at changing the code for the process file section now. Now there's a very minimal amount of change because the body of the function isn't going to change at all. What is going to change is the way we declare the function. Again, this will be conditional compilation. If we are running threaded, then we want to do something slightly different. So if we're not running threaded, we will compile that line of code. If we are running threaded, then we want to do it slightly differently. So we precede the function with thread. So it's thread function, the name of our function, and the variable we have to pass by value rather than by reference. And that's the only change. We haven't made any change to the body of the function, just the header. So let's do a quick check to see we haven't missed anything. We haven't. Now, we saw how long it took to process the last time. Since we've got our run threaded in place, let's try running it now. Now you'll see it's outputting entries for both section 1 and section 2 at the same time. So because it's doing both of these concurrently, it does actually finish up quite a bit faster. It's now taking a mere 13 seconds to run. So we can see the two output files, updated current emails 1 and 2. So if we look at number 1, it has in it the details that were there originally, plus it has the new email address of that particular user. So if we ran it for 3 sections, and we take our threaded variable off and compile that, it's now going to be running not in threaded mode. So we'll process each section one at a time. We'll see how long it takes to process 3 sections. Again, they're all using 5,000 records. So that's the first section processed. It's now sweeping through the second. And after that, it will move on to the third section. And we're on the third one now. And this will actually produce 3 files. Took a total of 38 seconds to run the whole thing. And there are our 3 files. So by changing a single line of code and recompiling, we'll see if we can beat the 38-second runtime. And there we are processing 3 at the one time. And there it took a mere 13 seconds. So adding a third section to the processing took it no longer to run at all. Now, what kind of impact does that have on the system? If we show each of our processes in the top right hand corner, and we'll run this unthreaded, and we'll see what kind of load this has on the system, we'll drop back down to 2, compile that, and run our program now. There we are running, and we can see that one of the CPUs is running at almost 100%. This is because the program is running in a single thread. And at any point in time, that CPU is the only thing that will actually be working. Now, obviously, the more CPUs you have on your computer, the more other things you can run in the background. Now, that took some 24 seconds to actually process. So if we run it again, but this time we will run it multi-threaded, and we'll see what effect that has on our processors. Now you'll see that two of the processors are now running at almost 100%. So what the multi-threading actually does, it creates an extra thread of your process and runs it on a different CPU. This is down to Windows actually balancing out the load of all the work being done on the system. So the more processors you have, the more threads you can run. If we up this to a larger number of threads, let's say we go for 10 threads, in this case we would be processing 50,000 records, which is half the total number. If we run this now, there we go. We'll see that looking at our CPUs, many of the CPUs are now running fairly high. And it's shooting through the processing really quickly. There we go. 26 seconds to process 50,000 records in 10 threads. And our processors now return to normal. So if you can divide your work into sections, and each section can be handled by a separate thread, you can radically ramp up the speed at which you can actually process. But that's it for today. Thank you for watching.